Hi, everyone. Welcome to Engineering Product Innovations for Future Mobility. And this session is really going to focus on 3 winners from the Altair Enlighten Awards this morning and some of their excellent solutions as we look at new forms of mobility, electrification, autonomy, and then even as we move into ultra lightweight vehicles, new energy vehicles, etc. When we think about the future of the mobility ecosystem. So I have 3 fabulous speakers for you today, and they're going to describe what their innovation was. And then we're going to take time for Q&A. And as I always say, I've got some canned questions, but your questions are really, really important to be submitted as well. We have fixed the problem that we had earlier today, so now I can see your Q&A. So without further ado, I'm going to go ahead and begin to introduce the speakers, and I'll introduce them, then they'll give their presentation, and we'll go from there. The first speaker is Craig Renneker. He is the Vice President of Driveline Product Engineering for American Axle and Manufacturing, better known as AAM. He joined AAM in January of 2019, and he's responsible for all product engineering activities for the Driveline division. Actually, he retired from Ford Motor Company after 18.5 years as Chief Engineer in Transmission and Driveline Engineering, and oversaw the development and launch of 18 new automatic transmissions, hybrid and electric drives. Prior to Ford, he spent 9 years at FCA and 7 at GM, and always in the transmission department. He has a bachelor's degree in mechanical engineering from General Motors Institute, yes, now Kettering University, and a master's degree in mechanical engineering from Stanford. Craig.
Okay, thank you. Thank you, Carla, for that introduction. So a bit of an introduction about AAM, American Axle. You may know us for years as being a Tier 1 provider of axles, all-wheel drive systems, engine vibration control systems, and recently we're growing into electrification. We've got the Jaguar I-Pace drive units that we're very proud of, and what I'm going to talk to you about today is our acceleration and our growth full force into electrification to really grow that business. So we've got a little bit of a video that we're going to run to give you an idea of what we're working on, and I'll talk to you specifically about the innovation that we submitted for the Altair Award today. So we'll run our video.
Move over internal combustion. Electrification is here, and AAM is ready. We're highly prepared for multiple vehicle segments, scalable volumes, and an infinite number of challenges and goals. Breakthrough products ready now. A pipeline of innovations on the way. We're ready to go and ready to grow.
Okay, what makes us unique at American Axle in terms of innovation? I really believe that our teams are limited only by Isaac Newton. Our 3 primary pillars of the company are operational excellence, quality, and technology leadership. Well, you can't have technology leadership without innovation, so it's absolutely core to our survival. We see enormous opportunity by engineering the gearbox, the motor, and the inverter all together. There's huge synergy opportunities for those all to be together. Our partnership with Inovance is very important to us, and we're very excited about it. They know all the car companies in China. They've got connections with them, so that helps us gain access to that market. They also have access to all of the raw materials and components that we're going to need to build inverters. What makes AAM uniquely positioned to bring the future faster is this combination of our innovative environments. We produce where our customers need us to produce. We engineer where our customers need us to engineer. And whether that's a vibration control system or a traditional axle or an electric drive, that advantage is the same. We are where our customers need us to be.
Our vision for electrification at AAM started back in 2010. We've been involved in this space for a number of years. As many people know, we brought the Jaguar I-Pace drive unit to the market. A lot has changed in the market, but what hasn't changed quality matters. Delivering on time, every time matters. The trust that our OEM customers have in us is very important, and it matters in the conventional space, but it matters in electrification. We take a first principles approach to how we engineer product, and we look at what is the absolute limit of what we can achieve. By pushing those RPMs higher, we're able to get the same amount of power with much less active material. By deeply integrating the inverter, we're able to find cost synergies, design synergies that overall reduce the cost of the product. Craig and his engineering team have pushed the boundaries of what can be done in the eDrive space. They've not accepted the answers that are in the market today. Benchmarking, from our standpoint, is looking at the rearview mirror. What we're trying to do is we're trying to break barriers and produce products that aren't in the market with attributes that nobody's seen today.
At AAM, our next generation 3-in-1 electric drive systems package best-in-class power density with leading efficiency. With a 10% improvement in mass efficiency, 40% improvement in volumetric efficiency, and a 40% improvement in power density, it instantly becomes the new benchmark. Scalable and modular, AAM's 3-in-1 technology can power a wide range of P3 and P4 vehicle segments and electric propulsion architectures. The same technology used in a wheel-end motor is designed to serve in a single motor application for rear wheel, front wheel, and all-wheel drive vehicles. From there, we add power to propel even the most rugged vehicles, including heavy-duty applications. From small and light to powerful and adventurous, AAM's 3-in-1 technology is always quiet, compact, and efficient. With OEMs demanding performance and investors demanding returns, it's time for gasoline to share the road and the glory. AAM, bringing the future faster.
Okay, I'm also surprised to see they got my father to appear in that video, you know, so. Painful to watch yourself on TV here. So let me talk a little bit more in detail about what we brought to the Altair submission this year, and that's our next generation electric drive unit. And as you saw, it provides some substantial benefits to our customers, and the pillars of it were we drove the motor speeds higher. We realized the only way to make an electric motor smaller and lighter is to make it spin faster. So we're looking at a motor that will go between 24 and 30,000 RPM, which allows us to substantially reduce the package size and the weight of the active material. And the weight of the active material drives the cost of the unit. So substantially lower cost in the motor itself. But making a motor spin faster is easy. Getting it to live inside an actual automotive application is difficult. So we've got a lot of innovation in our gearbox that enables that high speed to operate without any problems with sealing, bearings, any of that. The second pillar was full integration of the inverter. I mean, the first wave of electric vehicles made a lot of sense. You partner with someone to make an inverter, you partner with someone who provides a motor, you build a gearbox, you bolt them together, you find a place in the car to put that big inverter box, you run some expensive orange cables, and it works. And it does work quite well, but it's very package inefficient. So the next wave was to take that inverter and bolt it to the motor in the gearbox. That's better, but we're going a step further to fully integrate the inverter into the drive unit. In fact, you can't even see the inverter on this because it is nestled, buried right inside right at the end of the windings of the motor. So the other innovation that makes this all happen is we're using a single fluid to cool and lubricate the whole box. So the gearbox lube cools the motor, cools the inverter, and we get some substantial efficiency improvements out of that. So the net result is we deliver 10% improvement in mass efficiency, 40% improvement in package volume. This thing is very small, so we can deliver a lot of power in a very small space, and that improves the power density. And then the reduced parasitic losses also improve our range, because none of this reduction in size has come at any compromise for efficiency. And so we really think it's a very exciting project to be working with. We're very honored to receive the award from Altair today because we use many of Altair's analytical products to deliver this thing quickly. We developed our software using Altair embed. We use many of their other packages to engineer every one of those parts before we built the prototypes. So that's a quick summary of what we've been working on, and I'd like to turn over the podium. Okay.
Thank you, Craig. Love seeing the video. I've got lots of questions that I didn't even know I was going to ask till you showed that. So I'm ready to go in a little bit. But second speaker is Shalaj Gupta. He's the Director of Marketing and Performance Improvement for ArcelorMittal North America. He joined the company in October 2015 and is now in the Southfield office, and he's responsible for leading the development of strategy for the automotive business in North America and supporting growth plans for the non-automotive business in Mexico. In March of 2020, he assumed his current position as Director of Marketing and Performance Improvement. He joined the group, ArcelorMittal Group, in 2008 in the corporate headquarters in Luxembourg in Europe as a manager, international business development. And since then, he's held various positions in the organization in managerial roles, investment strategy, marketing, shared services, purchasing, and supply chain. So you can ask him about anything and he'll have the answer. So he has an MBA from the Rotterdam School of Management, Erasmus University in Rotterdam, Netherlands, and a bachelor's in electronics engineering from Mumbai University in Mumbai. Shalaj, the stage is yours.
Thank you for the kind introduction, Carla. Hello and good morning to everyone. My name is Shalaj Gupta, the Director for Marketing and Performance Improvement at ArcelorMittal North America. First, would like to thank Altair and Carla for this opportunity. I'll be presenting on a slightly broader topic on the next generation steels that we have and are coming up with for the future of lightweighting, and also touch upon the award that we received for the product. But before that, we'll start with a short video.
Automotive manufacturing is evolving rapidly, and so is ArcelorMittal, the world's leading steel and mining company. Over 2/3 of a car is typically made of steel. With so much at stake for our environment, automakers need their vehicles to be lighter, stronger, and more sustainable, and that means steel needs to be smarter. The advanced high-strength steel we make today is 6 times stronger than it was 25 years ago, and our steel is evolving to meet the needs of the automotive industry as it transitions to carbon-neutral mobility. Our smarter S-in-motion steel solutions are lightweighting automobiles, protecting batteries, and providing a safe structure for electric vehicles. ArcelorMittal invests heavily in R&D to create steels, steel solutions, and steel-making processes for the future. To ensure our innovations match their changing needs, we embed resident engineers at our customers' design and engineering facilities so we can be proactive on translating their needs to affordable steels.
What we do is find ways in which we can use some of the newest steel products that we develop and incorporate them into various part designs that the automotive engineers can work on.
Working closely with the OEMs is critical because they start looking at the steels they'll need 4 to 5 years ahead of the model launch.
We also help them make sure that every part that we help them design or any new idea that we come up with are parts that actually can be manufactured. So there are a lot of computer-based simulations to ensure that the parts can be stamped well.
We are driven by expertise. Our research is global, enabling us to provide the best solutions to our customers. To visualize our new smart BEV steel solutions, an online car configurator shows how our range of advanced high-strength steels and smart solutions can meet the lightweighting, safety, cost, and sustainability performance targets of BEV producers. As we seek a carbon-neutral future, ArcelorMittal steel is the material that drives change.
So building on a few quick highlights about the company, we are the world's largest steel and mining company, serving customers in 160 countries and manufacturing steel in 17 countries. With more than 168,000 employees, we are not just a company, we are a community. Our scale and scope means that we are the only steel company that can truly leverage the global best practices across different regions of the world. For us, an invention or an improvement in efficiency can quickly transform into reality in our day-to-day operations. Our commitment is to be at the forefront of the next phase of transformation by inventing smarter steels for a better world, by being a technology leader focused on sustainable product and process innovation. A few key quick facts about our global research and development. So today there are thousands of grades of steel, hundreds of which did not exist 10 years ago. Just in the last 10 years, we have doubled the strength of steel, and in some cases, doubled the formability at the same strength levels. Just think about that relative to the changes in the industry. These new steels, many of which were developed by our scientists and engineers, push the boundaries of what's possible. We have some of the best and the brightest people in the business, engineers, who want to work for us because they get to tackle some of the most complex problems. Of the 1,500 researchers listed here at ArcelorMittal, at any given point in time, somewhere in the world, about 600 of them are actually working on auto-related activities. So, what are we doing to prepare for the future? Constantly innovating. And how do we do that? It all starts through our strong co-engineering efforts and the resident engineers that we have. Here's a fun fact. In 1990, ArcelorMittal was the first steel company to actually have a resident engineer within an automotive customer. And here we are, more than 20 years later, we have resident engineers either within or near design centers of almost every major automaker. The next one, the global hot form product leadership is based on a strong portfolio of patented products and solutions with up to 10 additional options being developed right now. The third generation cold form products, we are leading the way in North America. Fortiform 980, the award-winning product, is only one of them. These grades provide the best formability at high strengths, thereby enabling it to be designed by automakers in their vehicles. A mobility future that features electrically powered and autonomously driven vehicles will bring major change in the way OEMs are designing, engineering, and the materials which they use to make the car of tomorrow. As the definition of personal mobility changes, steel's value proposition and continual gains in performance will ensure it has a central role for decades to come. Innovations in battery technology make it possible for OEMs to continue achieving the lightweighting and driving range goals more cost effectively with steel versus other alternate materials. Hyperloop is just one of the many mixed mobility concepts for the future. We are exploring a lot more avenues with steel. Our philosophy, right steel for the right application. And as I just mentioned a couple of minutes ago, we have thousands of grades to meet the mobility needs of our customers. And if not, we'll invent one. So this is one of our product development axes of PHS, or what we also call hot stamping steels, which are specifically developed for press hardening and offer strengths of up to 2,000 megapascal. The Ductable product family listed on the top left has already shown 15 to 20% lightweighting versus the first generation. And the next generation, we're already targeting another 10% weight saving. The Usabor family of products, which is further to the bottom right, has led to 10% weight savings versus the previous generation, which is over and above the benefits of conventional AHSS. Interestingly, the first use of usable 1500 was actually back in 2001. The usable and ductable grades, our patented products, can also be combined thanks to laser welded blanks. What this enables is significant lightweighting with optimal crash protection and higher corrosion protection, thereby giving primary applications in safety and structural components such as front rails, rear rails, B-pillars, and most importantly, the innovative door ring solutions, which were also shown in the video, and flooring solutions. Oh, and to mention, all of these grades and products are available in every major auto producing region around the globe today. For the next generation PHS products, we are focusing on breakthrough ductility, enhanced corrosion resistance, and optimizing hot stamping costs to ensure that they further support the lightweighting of vehicles. Another product family, which is the third generation, or Gen 3, for AHSS, or Fortiform as we call it, which allows OEMs to lightweight structural elements using cold stamping. Fortiform products are produced using quenching and partitioning process that creates a unique microstructure, translating into a combination of high strength and exceptional formability. We've already achieved 10% lightweighting versus the standard DP grades. The next generation Fortiform S products would further enable lightweighting at these higher strength levels with formability, with weight savings of up to 20% versus the conventional HSS grades. Getting into the Fortiform 980, the award-winning product in the lightweighting enabling technology category, it's actually now been adopted in vehicles recently launched, and they're already on road. From a mass perspective, it offers the ductility of dual-phase 600 at these high strength levels, allowing complex shapes to be formed. It has demonstrated reduction of thickness by 10% or 20% while achieving the same energy absorption levels for these parts. And the 20% weight savings, that's already been validated by our OEM customers. From an applicability standpoint, how did we get this product selected by customers? It all started with our co-engineering efforts and customer engagement going back to 2016. That's 5 years ago. And this led to innovation after thousands of hours of simulation, lab tests, trials, stamping trials, customer qualifications and trials, which finally led to the adoption of these products. Our product was found to demonstrate superior liquid metal embrittlement, or LME resistance, in an auto steel partnership activity, thereby establishing a benchmark in the industry. Through our early vendor involvement, we ensure smooth launch for any product, just as we did in this case. So, where are we heading in the future for breakthrough products? It all starts with the weight of the car, as we've heard in different presentations, which is key to its fuel efficiency, but the challenge is to improve it while also ensuring safety, cost efficiency, and recyclability. Hence, we are focusing further on 3 key areas of the vehicle, starting with panels for thin sheets for inner and outer panels with flexural stiffness solutions, the structural parts, high strength, high formability with cold stamping, and the high young modulus or lower density for the chassis and BIW applications. As highlighted earlier, we are also developing smarter steel solutions for the battery protection, chassis and body-in-white applications of BEVs as the latest extension of our S-in-motion range of steel solutions. In a nutshell, we are actually a technology and solutions provider that just happen to produce steel. With that, thank you so much.
Thank you very much, Shalaj. I also have many questions now for you too. And our third presenter is Hank Richardson. He's the Product Engineering Manager in North America at L&L Products. He's responsible for the CAE team and for the overall global development of L&L's continuous composite systems product line. He's been with L&L since 1996, where he started in manufacturing as a project process engineer. From there, he transitioned to the commercial team in product development in 2000 and helped lead the development of L&L's composite body solutions product line to a point now that nearly every passenger type vehicle built has structural inserts which help each vehicle become lighter, stronger, and quieter. He's a graduate of Michigan Tech University and lives in Romeo now. Go ahead, Hank.
Thank you for that kind introduction. So in my presentation, we're going to try to go through the development that we had here, but as Swami said this morning, you know, a lot of great developments happen when you bring multiple companies together. So hopefully I can showcase this, the interaction between BASF, L&L Products, and Stellantis, as well as describing the new technology. So we started working on the project for the Grand Cherokee. It's a composite tunnel reinforcement. So you might ask, what is a composite tunnel reinforcement? So hopefully we can describe this in the video that's coming up here. From Stellantis came to L&L. We did like a tech fair for him, and we went through all of our product lines, but we showcased the pultrusion and the CCS, and then he concepted a specific part for us, and then we went from there. The traditional solution that Stellantis had was steel that is heavy, and they were looking for a weight reduction in their vehicle.
Having a pultruded insert that's overmolded with a thermoplastic with inserts allowed us to develop something that hasn't been used before. And we had begun discussions with L&L on this, and it moved into a co-development. So it took 4 years where we were actually trialing our initial localized formulations at L&L Products. With that came all the know-how. So we shared that know-how moving forward, not only finalizing the formulation, but then with processing, and then most importantly, the CAE analysis, where we actually came up with a methodology to accurately predict it in a physical model. This is replacing the original concept of a high-strength steel clamshell with steel inserts. This is required to pass some of the safety requirements of the vehicle. So this is actually during the shallow offset barrier test where the car runs into a barrier and the load is actually transferred from the rocker panel to this component. So it's actually transferring the full force of the vehicle going into a barrier over to the other side of the vehicle.
We validated this design in their full vehicle model to meet the performance requirements that they had. We created sub-models that we could then test in the laboratory.
Regarding magnesium, aluminum, or steel, even ultra-high strength steel, our strength-to-weight ratio is 3 times greater than any of the metal solutions out there today.
We were able to package our part in a slightly smaller configuration than the steel did, as well as a way that we designed it into the system, we were able to take mass out of other associated parts in the system.
Well, after this first application, I think we really opened up into understanding where else we could go with it, and it is anywhere in the chassis where it's dominated with metal today. So rocker panels, cross-car beams, door intrusion beams, crush cans, bumpers, especially for the new drive with e-mobility. We were looking at battery protection, all kinds of different structures that are required for enhanced occupant protection, and especially working with L&L Products, who understands the process of developing methods to create different shapes and different ways to sweep the profile. The opportunities are almost limitless.
The neat thing about this launch is we did so much work up front in the prototyping and validation that this part's actually launching like any other part would launch. Very little fanfare at the OEM. That's a good thing.
The lower weight contributes to better CO2 emissions and better gas mileage, and the overall cost of the system in raw materials is less than steel,
which could really make this a game changer. So you could see it truly was a partnership and innovation. So as we went through this, this part at its heart has a pultrusion insert inside of it, and then it's overmolded with a thermoplastic. So in doing all of these to create this part, we believe there was a series of firsts in the industry. So for Stellantis, this is the first composite of its type on a very high volume production car. Second first was the resin system is new. This resin system comes from BASF, and then we were using it at L&L in our CCS systems, and it's the first time that this polyurethane system has been launched on a part like this. The overall design of this actual part is new. Stellantis gave us some freedom to be able to package it different, which allowed us to save some more weight, and we truly think we've got innovative here. The next thing that was incredibly hard to come up with was a new methodology for modeling composites. Composites are difficult to manage in a CA situation, especially if you're in a crash scenario where you're going to see failure in the part. We were able to manage to launch that new system. Other industry first is the ability to take that pultrusion at rate, at very high speeds. We are more than 2 to 3 times sometimes what the industry standard is as far as what pultrusion runs at. So that makes it more efficient. When we look at the overall part, maybe some of the real magic was made here in this hybrid system. The fact that we're bringing in multiple components and we're overmolding it into one complete part. So for Stellantis, you know, the first, to be able to launch it on a high volume car, they really had to fast track us through. So we did a lot of development, both internally at Stellantis, at BASF. We did a ton of development, but it helped us. And like I said in the video, it was very little fanfare. It meets what it needed to, and it exceeds its functional requirements. As far as the new resin system, that BASF had brought to L&L and we helped co-develop on our lines. It works fabulous for us to get the rates that we need to do. Good wet outs, excellent mechanical properties. It's a very high volume fraction of glass, so we get incredibly good strength out of this. When we look at the design, we mentioned in the video that we replaced a clamshell high-strength steel component. We did that by developing this part and taking what we heard from some of Stellantis's assembly guys and saying, you really need to be able to do this and do that. And so it really helped us package this up farther in the vehicle. We added things to this that makes it so easy for the guys in assembly. They snap it in, and then they can come back and put the bolts in with both hands. As I mentioned, the manufacturing process that I'll talk about in another step, but as you can see in the slide, there's 9 different components that go into the injection molding machine to be overmolded. So that was a tremendous amount. The computer simulation that we talked about, as you see the chart on the screen in the dash line, typical composites can take a part up to failure, but then they catastrophically fail in CAE. That is not true in reality. You get some fibers that start to break, but the beauty of composites is they can really carry a load through in an entire event. And it's that energy after initial failure that we were able to capture. Working with BASF, and even some of the experts at Altair helped us with some ideas on how to create this. But this has been a real game changer for energy management with composites. I mentioned the line speeds before, trying to make this economical. We are pultruding at rates that far outruns any of the industry standards. But this hybrid solution at the end, where we bring together all these, L&L is open for visits, and to see this injection molding machine is quite a marvel. We have 3 different robots on it. We're picking up all those 9 different components, placing them, we're scanning them, we know what they are. These parts go into a rotary injection molding machine that puts everything together. Everything is scanned as it comes out. We even put a born-on date with a laser at the end, and then it's put onto a conveyor. So this hybrid system is a very unique and great thing for this part. So in summary, the composite tunnel reinforcement, first in the industry like this. It had a 40% weight savings for the component level. It had 20% savings for the overall system that it was working in. It also brought a cost savings. So one of the big things that we were worried about is, are you doing something that's lightweighting but is cost neutral? In this case it was. It's not only cost neutral in piece price, but it was a savings in tooling compared to the other one. So our lower environmental impact, we're using less materials. The vehicle is less weight, so we can get better fuel economy. The functionality exceeded everything that we needed to do with this part. The new computer tools that we developed to be able to simulate this is excellent. And then this new manufacturing process. So here was the team from the 3 different companies. A big thank you to the Stellantis and BASF team for helping us, and then the L&L manufacturing team was outstanding, some of the things that they came up with. So other targeted applications that we could possibly do with this, we see the sky as a limit for this, this technology going forward. So thank you very much.
Thank you, Hank. Before I forget, you mentioned, you invite people to come and see this great piece of equipment. At CAR, we have a coalition for lightweighting automotive materials, and we often take field trips, so I'll get back with you on that.
Yeah, we'd love to have you.
Yeah, that would be great. I do have some questions submitted. I'm going to start, though, with, all 3 of you, very kind of different areas, propulsion, metals, composites, but all of you talked about increased speed and increased, earlier development and co-working with your client. Tell me a little bit more about that, and maybe some of the tools that have been developed to enable this earlier work and faster work. And you especially mentioned about quality and speed together. So maybe we could start here, and Brian, you can explain to me, what you meant by that, and then maybe I can hear from the others how they're working differently or what tools you're using to enable that rapidity.
Okay, we use a variety of analytical tools for every aspect of the design. The one I mentioned, I'll expand on a little bit because I think it was a really great example of how to move quickly. We developed our own inverter from scratch, and I'm proud to say that was done. We're a global organization, but all that work was done right here in Michigan at our tech center in Detroit. And developing the software from scratch to drive an electric vehicle is a pretty daunting task. But we were able to use Altair embed software, which made it very fast, very easy to iterate, and it had a lot of existing tools within it to provide the ability to do motor commutation and all the things we needed to do. We were able to get this vehicle running in just a matter of months with 2 software engineers. And we have companies out there looking for, we need to add 1,000 software engineers. So the idea that we can get a fully viable prototype electric motor running with 2 software engineers is testimony to the tool. And then we've applied other Altair tools in many other places to help us get from the concept to hardware substantially faster than we normally would.
Thank you. Shalaj?
In our case, I would say it all started here with the needs of the customers based on our relationship and the co-engineering efforts. The customers obviously wanted to lightweight, and we went back to the drawing board. We drew upon the global expertise we have in the company. There were a lot of simulations, a lot of trials, a lot of back and forth, and eventually we came with a product that not only met the needs of the customer, but also demonstrated additional parameters and additional benefits in terms of lightweighting, corrosion protection, and formability. So I would say it's an iterative cycle, and the speed, 5 years, may not sound like a quick outcome, but I think in our world, it is a pretty good outcome.
So for us, I think we're a little bit of at a disadvantage with that, because all of our customers, they bend steel, they form steel, they weld steel all the time. So they don't always start with composites. So we really need to bring customers in, do tech fairs, show them what can be done. It really helped with the partnership with BASF, because we were jointly cultivating customers and showing them what they could do. And then for us, it's really finding the people that will be those adopters and that can believe in composites. So, you know, that's a real key for us to getting it started. And then you have to have something that they want to use. So it took us probably 5 years to perfect the CCS technology to a point where we could bring it out. And so early development, educating customers.
Yeah, I think that education piece is really interesting. We've talked about composite materials for years. Why is there still reluctance or hesitance? Do they just not understand the latest, you know, breakthroughs and developments, and those have to be explained, or some of the old ways of thinking have to be, you know, dissolved, or what?
I think so, to a certain point, yeah. So again, they use metal and all the time in aluminum, so trying to educate them and then show different applications. Shalaj probably, you know, shows different types of metals, and all the engineers understand how to use it. Okay, I have to teach the CAE people, you know, how our modeling works. We have to educate them to a far greater degree.
Are you finding anything similar in the steel industry with everything that's moving so quickly that, you know, people need to be educated as well to understand the breakthroughs that are happening?
Well, I think the education aspect is there because it's a new grade at the end of the day. How it behaves, how it performs, all of that needs to be validated with the customer. And an interesting point, just to build on what Hank said, the investment was on our side. It was a $45 million investment to get this product, but thankfully there's no investment on the customer's side. Mm-hmm. And they can assemble it, manufacture it with the existing equipment they have. So that made it easier, for sure. Mm-hmm.
And I'm going to take a question from the audience now. And first of all, I apologize. I called you Brian, and your name is Craig. I don't know why. Maybe you look like a Brian I knew, you know, in my previous life or something. But my apologies. I won't do it again. And the question from the audience is, you showed gains in efficiency in the 4th generation electric drivetrain. And it says internal combustion engineers would kill for such percentage gains. You know, can we talk about the trend in improvements? How many generations until gains are down to 2 or 3%? And why can such gains be made? Are engineers still learning? Is the technology in its infancy? What's the trend line for improvement? So a little future modeling is what they're asking about.
Well, I think the pressure to improve efficiency will never stop. It will just keep going. I think in our case, the breakthrough was we realized a lot of benefits by just making things smaller. If you make the motor smaller, the bearings can be smaller, and there's less drag there. And then we designed the gear train in such a way that there's very, very little oil churning. The gears churning in the oil eats up a lot of power. So we were able to minimize our motor mechanical losses, minimize the gearbox losses, but then also in the inverter, there is still a lot of opportunity to make the inverter more electrically efficient, and more electrical efficiency provides greater range for the vehicle because you have less battery power there. So the way we've designed the inverter using silicon carbide, MOSFETs, and oil cooling makes it very, very, very efficient. And so the whole bundle provides an efficient package. And we'll just continue to go after that. We'll see what other ideas we come up with as we develop, because that pressure is not going to go away.
So let me ask you another question while we're speaking with you. And you showed on one of your slides, the scalability from a very, very small vehicle up all the way up through a commercial vehicle. And I think that's kind of what everybody's looking for now is this, ability to be able to scale throughout the various, mobility ecosystem. Does electrification help that scalability, or is there no difference from internal combustion to electrification in terms of scalability?
Well, as you mentioned in my background, I spent 18 years with Ford and other companies developing internal combustion engine drivetrains. And to span from a small vehicle with a 3 or 4 cylinder engine to a very large diesel 8-cylinder, it's very difficult to get one product to cover that range.
Sure.
Electrification does seem to be more scalable. You can make the same basic concept of the motor can be made a little bit longer or a little bit larger, and you can cover quite a range in the power level of the vehicle. So we're quite surprised to see in our product lineup, our platform lineup, that from basically a C-size vehicle to a heavy-duty pickup truck, that same technology can be applied, and it doesn't change as radically as you have from a 3-cylinder engine to a V8 diesel. So I do think there are some inherent features of electrification that make that scalability a bit less painful than the IC world.
And then also on the materials side with the steel and with the composite, are you seeing, I'm sorry, I've got a note telling me to use this because I noticed my voice is not really doing very well with this. So, are you seeing the same thing as we're shifting to electrification from internal combustion? Are you seeing more pressure for lightweighting and for more unique solutions in the electrified world?
From a lightweighting perspective, I think we are actually, the lightweighting is not going away, but it is definitely dropping in terms of the priority for OEMs because cost is taking a precedence, right? Cost is actually a higher priority for them versus lightweighting. And in terms of the solutions that we have, a lot of the solutions that we have worked on the ICE side are applicable on the BEV side as well. It's just a matter of, with this new range of products, when we are working with customers, we're working on all the 3 Gs. By the 3 Gs, I mean grade, gauge, and geometry. And the last, with the geometry aspect, with the latest invention of the 40form, it opens up a whole new range of possibilities for formability, which helps. I think we heard in the previous panel as well that aerodynamics is another aspect that everybody's working on. So it just helps in all these aspects.
That's really interesting because, my brain was thinking that, as we have electrified vehicles and as we want longer range to meet the consumer demand, we need to have lighter weight product as well, and batteries are heavier. So
if I may just develop on that a bit more, I think with the electrification, the whole lightweighting pressure was basically built because of the tailpipe emission regulation, right? That's where we started. And now with electrification coming in, the pressure is off the tailpipe. We are now focusing more on making these vehicles more efficient, and the battery packs are heavier, but there's no pressure on the tailpipe. So it just takes away that pressure a little bit from the lightweighting aspect.
And what are you seeing in the composite world?
So for us in the composite world, the electrification has been amazing amount of work. We've got all these new customers. They're learning about it. They want to see lightweighting, but they also have limited staff sometimes. So we're really trying to help work through all these different solutions and areas that they may need help in. For us, it's been a real boom, whether it's battery boxes or vehicle structures. I mean, the vehicle structures are, let's just face it, they're different than what an internal combustion engine is. So there's a lot of learning going on, and with our structural inserts, we've been able to really help out in a lot of ways.
Yeah, I know in the judging process for the awards, we were looking strongly at both cost and weight. Those that were able to reduce cost or at least keep it on par and reduce weight, those are the, got a higher score. So I think most of your solutions fit that model. There's a gentleman that is asking about innovation and some of your young professionals coming into the company. In fact, he asked 3 questions about it, and they're similar. I'll just go through them. Do young professionals have enough education to deliver innovation? And do you have any advice that will help young professionals contribute to the future of mobility? That's his first question. And then the second one was about the difficulties of product innovation lie in the complexity of ideas or in the primitiveness of the tools used to make the proposed innovations. Like, do we need better robotics? And then also talking about product innovation, should we think about standardizing for the future of mobility? So let's kind of first talk about innovation within your companies and, thinking about some of the employees and what drives innovation, or what methodologies might you be using in your companies to drive innovation? Craig, why don't we start with you?
Yeah, I can say a few things about that. One, we try to create an environment that encourages innovation, and that means a bit of risk tolerance. You have to communicate with people that it's okay to take a bit of a risk, because many innovations just plain fail. So we have to create that environment that says, try it, go ahead, take that risk, and we will work with you. And the idea is to get enough successes that it offsets the parts that don't work. Another element that we have done is to try to focus our innovation team such that we kind of keep them out of a lot of the day-to-day operations, such that they can have a little bit more freedom, a little bit more white space in their day to innovate and to think more creatively. And with that, I think that was one of the things that helped foster our Gen 5 drive, because it got people innovating on finding a way to design an inverter motor gearbox altogether with no other limitations. And that's another element we talked about in the video. We like to encourage people. Our only enemy really is Isaac Newton. Let's fight that. Fight the basic physics, get to the basics, focus on those basics, and the innovation seems to come from that. So, few of my comments.
Great. And Shalaj or Hank?
I think quite similar, echoing to what Craig just mentioned. It all starts with the culture that we have established in the company, because we want to foster innovation without the fear of failure, because failure obviously helps teach us and become better at what we are doing. So we encourage our researchers, our employees, and everyone to actually come up with ideas, think outside the box, and come up with solutions which meet the needs of the customers, but also try and exceed the needs of the customers, because the need today can be met, but we are actually trying to think ahead on what to anticipate. And in an ACE's world, right now all the focus is on electrification. But going forward, I think when a vehicle is being driven autonomously, it'll still be subject to those risks of crash. So how do we ensure that we have the right steel grades for the vehicle of today and tomorrow?
So I agree with both these guys. So definitely it's culture, and it's removing that fear of failure. And we actually have a saying at L&L, we know you're going to fail, but let's fail faster. So we have to fail faster because that's where we learn. So the quickly we get through all these examples, and you just never come up with the exact answer the first time. You have to continue to evolve and work through it. So that's been in our culture at L&L for a long time. So it's one of the great things that I love about working there. It's the innovation. It's the no fear of failure. And then, I think part of your question was, how do you get the young people? Are they, we bring interns in. I mean, one of my lead engineers right now that was on this part was an intern for me 6 years ago. And so just bringing them through, and you're just cultivating it from within. And so that's a great thing.
Go ahead.
If I may just add to that, I think to address the second part of your question, we need young talent. We need people to think differently. The way we used to do things before may not be the way we'll continue to do things. And that happens with somebody who's bringing in a fresh perspective.
Absolutely, absolutely. And I loved hearing, go ahead and fail, but fail faster. And I think that kind of goes along with the other question that was asked then, what are the tools that allow you to fail faster? What things have allowed you to do that? Because, what used to happen in companies, and your companies clearly aren't doing this, but innovative ideas would come, they would get into the machine of the company, and the machine crushed those ideas easy. And you're saying you're keeping them separate, that's one thing, but I think you also have tools now that allow you to be much faster so that big machine of product development cycle can't kill it because of timing. So can you explain some of those tools or how that's morphed and changed over the years?
Sure, I'll give you my perspective. Again, the analytical tools and also the CAD tools that are available do allow us to move faster and not rely as much on hardware iteration. So, the drive unit that you saw up there, we had full models of all the electrical circuits, full models of the electromagnetics, full models of the oil flow within the box, full models of all the structure, all done before we built even the first prototype. Mm-hmm. That used to take a long time, but now the tools are so quick and they run on a laptop and people can do it from their basement. We can get so much more analysis done in a short period of time. And then we also have partners at a tech center in India that work with us. So while we're sleeping, they're helping us do that analysis. Mm-hmm. So the organization and the tools just allow us to move more quickly. Then even on the CAD side, we can develop models and drawings faster than we could before, and that helps allow the innovation to move through the organization. I mean, purchasing can't help you if they don't have a model or a drawing that they can go talk to a supplier about. So if the innovation team can develop those quickly and have those documents for manufacturing and for purchasing to work with, we can just get to market faster. So those are some of the ways in which the tools that have advanced a lot over the last 10 or 15 years mm-hmm. allow us to go faster.
Great. Any other comment?
I think similarly, the computer simulations have gone a long way mm-hmm. in terms of making us learn faster. Because in the previous days, obviously, crashing a vehicle is the way to find out, but it's not a cheap way to find out. So before we get to that stage, there are a lot of trials and simulations run with computer simulated models that help us learn faster and enable us to react quickly.
And I agree. I mean, the optimization through the virtual world is how it's all done, and we can do that faster. As far as developing it inside the culture of the company, we try not to, completely separate where innovation is and current product. Mm-hmm. We have a product development process that encourages everybody that's still working on everyday projects to run product development processes. It spurs the innovation internally across the entire team instead of just trying to think that innovation is just up to one person or one group. So we try to do it across the company.
Excellent. And I know we're out of time, but I'm going to start with you and just do a very quick question. What are you most excited about in the next 5 years?
For me, this new technology, we've come up with multiple different ways to use it. The CCS technology, we showed today how you can overmold it and use it in a technology. Well, we've also come up with adhesive technologies where we can add on parts. We can make bigger, multiple assemblies. I think the it's limitless of where we could put it.
Excellent. Craig. Sorry, I'm really shaking it up now. Craig.
I'm really, really excited to see our Gen 5 drive move from a demonstration truck to production. And that's what we see happening in the next 5 years. And it's incredibly exciting because we see how it can affect so many different vehicles with so many different OEs and so many different markets. And by focusing on improving that core technology, we can touch so many different places. And
Awesome.
it's really fun and exciting.
Great. Shalaj.
Well, excited with the pace of change that is hitting our industry and all the new innovations that are happening, and looking forward to being part of this journey in terms of how does steel play a central role. Steel has been around for 100 years, and I think we see that the same going forward for the decades to come.
Well, thank you so much to the presenters and speakers. If you give them a nice round of applause. And now you can go to your power lunch, box lunch, whatever it is that you need to do for the next hour or so. Thanks so much.